Chapter 1. The Explosive Beginning. The universe began with a fireball, approximately the size of a grapefruit. The fireball suddenly exploded, and first came inflation. Think of a balloon, but much faster. Then the universe continued to expand, but considerably slower. The radiation left over from the event is known as cosmic background. Some say because of dark matter. Hubble's law supports the theory that the universe is continuously expanding, stating that the farther the galaxy is from us, the faster it's moving. In other words, that galaxies are moving away from us at speeds proportional to their distance. A supporting theory for Hubble's law is redshift and blueshift. It backs up Hubble's law because it states that the farther a galaxy is away from us, the farther the red shift, which indicates faster movement, because redshift indicates that the galaxy is moving away from us, as blue indicates that it is moving towards us. The farther the red or blue shift, the faster the galaxy is moving away from us. Galaxies are large clusters of matter in outer space that can contain 10 million to 100 trillion stars. There are three types of galaxy: spiral, elliptical, and irregular. Our galaxy, the Milky Way, is 100,000 light years wide and 10,000 light years deep. A light year is the distance that light travels in a year, and since light travels 300,000 meters a second, a light year is quite a long way. Our galaxy is a spiral galaxy, not irregular nor elliptical. It has three spiral arms, one of which we reside in. Most every galaxy has a black hole at its center to keep the galaxy in shape. Our black hole is named Sagittarius A.
All stars begin as protostars. They form through an accretion disk, which is a small disk of matter, pulling other matter into it. A protostar is a baby star that has not gone through fusion. Fusion is when two atoms come together to form a bigger, different atom. Our sun also started as a protostar. After it fused, it turned into a main sequence, medium mass star. Medium mass stars live for about 10 billion years. After this, when it runs out of hydrogen to fuse, it starts to fuse helium and becomes a red giant. This causes the core to contract, and the outer shell to heat up and expand, and becomes a planetary nebula. After it runs out of helium to fuse, the outer shell releases, and the core dies, and the star becomes a white dwarf. All stars go through this process and die because when a star runs out of elements to fuse, the gravity pushing inwards becomes more than the pressure of the fusion, and the star either becomes a white dwarf if it is a small or medium mass star, or it collapses in supernovas if it is a large mass star. This is when the star explodes. It can also hypernova, which is just a bigger explosion. After this, it turns into a black hole, which has so much gravitational pull that not even light can escape when it is in its Schwarzschild radius, which is the area where the black hole's gravity has effect. Or it turns into a neutron star, which is a small mass star that is incredibly dense and has a lot of gravitational pull.
Dust. According to the nebular theory, our sun and planets formed around this very nebula. As matter converged, planetesimals formed, which would later form planets. The terrestrial planets, like Earth, were rocky, close to the sun, small, and dense. They were Mercury, Venus, Earth, and Mars. The Jovian planets, Jupiter, Saturn, Uranus, and Neptune, were larger, less dense, gaseous, far from the sun, and had a thick atmosphere. More or less, our solar system has been around in some form for 4.4 billion years. But Earth has only been how it is for about 500 million years. Matter began to converge due to gravity, and early Earth gradually grew. It became an unstable ball of molten rock. How did the moon form, you may ask? At one point, another planetesimal collided with Earth, and the debris from the collision formed the moon. Early Earth's atmosphere was full of noxious gases, such as carbon dioxide, hydrogen cyanide, carbon monoxide, and hydrogen sulfide. From here, our solar system and the objects that it's composed of formed and developed into those that we know today.
Life evolved through bacteria. It started out as single-celled and turned into multicellular organisms. All life started in the ocean. Earth's early atmosphere was actually toxic to humans until cyanobacteria evolved and started creating free oxygen. They did this through a process called photosynthesis. This process created oxygen. This turned our atmosphere into what it is today. Eukaryote cells also evolved during this time. They are cells with nuclei, but according to the symbiotic theory, they form through symbiosis. During the Phanerozoic eon, there are three eras: the Paleozoic, the Mesozoic, and the Cenozoic. During the Paleozoic, there was great diversity in marine life. During the end of this time, there was a mass extinction, where as much as 95 of the complex life in the ocean died. During the Mesozoic, there was dinosaurs and the appearance of flowering plants, or angiosperm. There were also gymnosperm, which were like pine trees. This time also had shelled eggs and reptiles. The next era was the Cenozoic, which is the age of mammals, where many mammals evolved. All organisms go through this process of evolution, in which they start as single-celled organisms and adapt according to their environment. They go through natural selection, in which all but the strongest die out. Then variation, in which species will split up into different subsects depending on how they evolved. This is all descent with modification, in which these organisms started from one original organism and kept descending through generations with slight modifications.